Welcome, everyone. My name is Vivian Mushahwa, and I would like to welcome you again to this month's Smart Talks. If you are joining us for the first time, Smart Talks is the monthly seminar series of the SMART Network at the University of Alberta. And as many of you probably know by now, SMART stands for Sensory Motor Adaptive Rehabilitation Technology. We are a network of more than 300 professors, support staff, and learners who have come together from many different disciplines to develop interventions that would improve quality of care and health outcomes, especially for persons experiencing neurological conditions. And today, it gives me great pleasure to introduce our Smart Talks speaker, Dr. Michael Lipsett. Dr. Lipsett is a professor of mechanical engineering in the Faculty of Engineering here at the University of Alberta, and he has an illustrious career in both industry and academia. Now, prior to joining the University of Alberta in 2006, he worked in research and development as well as in operations in the Canadian nuclear and oil industries. At the University of Alberta, he currently holds the Poole Chair in Management for Engineers, and he is the Director of Innovation, Creativity, and Entrepreneurship in the Faculty of Engineering. Dr. Lipsett's research interests focus on automating diagnostics to improve the reliability of complex energy and environmental systems, and he also develops robotic systems for remote and hazardous environments. And we're really very excited to have him with us this month, and looking forward to hearing all his experiences that he's going to be sharing with us, especially when it comes to entrepreneurship. Just a few housekeeping notes before we start. This session is recorded, and I encourage everyone to participate in the question and answer period after the talk. You can ask the question yourself at the end of the talk, or you can put it in the chat and I will ask it on your behalf. To preserve bandwidth, it may be a good idea to turn off your cameras during the talk, but it would be great to turn them back on during the question and answer session to get that feeling of being in a community asking questions. And with that, I turn it over to you, Mike.
Thank you very much, Vivian, and good afternoon, everyone. Let me try sharing my screen and we'll get going. I'm really pleased to have a chance to talk about the topic of taking our knowledge that we've created out of the laboratory setting and lifting it from the publications that we create to be able to create some additional value. So what I'd like to do is I'd like to talk a bit about what the challenge and the opportunities are with respect to commercialization and the steps that we might take to be able to create other impacts from the knowledge that we've created and the opportunities for the students that we work with in a more commercial venue. So that always starts with understanding what the real need is and what the limitations of current solutions have been before getting into a technology development and commercialization program. So I'll walk us through a number of those steps. Some of those I won't describe in great detail, just in the interest of time, otherwise it'll be a 4-hour talk. But what I will do is, Laura has already volunteered to distribute the notes from this talk, and I'd welcome anybody contacting me afterward to talk about some of the specifics of how you might see creating some additional impact from the work that you're doing. I'm often asked how commercialization is different from R&D, and it is very different. And it's because the nature of the impact that's being created and the processes by which that impact is realized are significantly different from the specific activities associated with research and development projects. However, they are part of a continuum, and I hope to give you an appreciation for what that continuum is as we go through the next 40 minutes together. But before you even consider a commercial opportunity, you have to think about what it would take to be successful. Right? Always begin with the end in mind. And for that, you need to think about the technical feasibility. What would it take for this technology to work and meet the requirements that the user or the customer would expect it to deliver? And the market feasibility really is all about the customer. So that is who has the need and how many of those people are there, and in what circumstance would the technology be applied to be successful. And I have a lot of experience in trying to take technologies to the point of operational implementation or commercial sale. And I'm hoping for good judgment, because one of my colleagues has a sign in his office that reminds us all that good judgment comes from experience, and experience comes from bad judgment. So I have lots of experience, and hopefully what I can do is I can help some of you to avoid some of the mistakes that I've made along the way, and to get to success faster. I've been a part of 3 startups, and I'm currently a technical advisor to 4th, and they're all different. And if there's one takeaway that you should have from this, that if you are considering trying to take an idea to market, it's not an individual's game, and it is and there's a range of expertise and knowledge that you need to have available to you to be able to get down that path. And I think you'll see as we go through some more of the rest of this talk just what that range is. Because when you get to the point where you have to have financial feasibility, there's 2 stages to that. One is to get to the point of delivering the technology to those who would be paying for it, and then ensuring that you've got a way to ensure that the cash flow from producing that technology is actually enough to support the effort to get it there. So from a market standpoint, it's all about the end user and the customer need, and sometimes those are different. The need has to be identified very clearly, and who it's for and under what circumstances. And then you also have to consider, how much is it worth in time and money to be able to solve this problem. And unfortunately, we had to think of those questions early, because it's a zero-sum game. All we really have is time ourselves. And if we need to find the other resources, people and money, then those require us to be choosy and focused. The earliest stage is not to begin the technology development itself, but it's to understand what the technology needs to provide for those who need it. And that's marketing. So I've been an engineering professor for 16 years now, and the 2 inconvenient truths that I share with the students that I teach, and I teach design, technology, risk evaluation and commercialization, as well as some more standard engineering analysis kind of courses, is that at the beginning, marketing is more important than engineering. And at the end, marketing is more important than engineering. And in the middle, engineering is technology at the right price. And so understanding very clearly what the need is and doing the technology development to meet that need is the right approach to be successful. There's 2 basic ways to do market research. The first is to talk to those directly who are potential customers or clients or end users, or those who will be experiencing the procedure, to get an understanding of what the need really is and what the limitations of current solutions are. And there's a range of ways to doing that, which again, I won't be getting into any particular detail in today. The second approach is, rather than talking to individuals directly, to look at information that has been gathered and collated by others. So that's referred to as secondary research. And that looks at population statistics, industry and sectoral information, academic studies, and so on. So there's a lot of work that has been done by others, which you can then put into the context of, is it worth it trying to solve this problem or not? When you're looking at how many people do you need to talk to, it needs to be, well, more than one. And the easy answer is the more the better. But the real answer is it has to be diverse enough that you get an understanding of what the real issues are, technologically as well as other aspects. And if it's a medical device that's for a particular patient, or if it's a device that will be used in a clinical setting as part of a diagnostic or corrective process, the people that you talk to are going to be quite different. If you're looking at solutions that are more, let's call it information-based, so software or medical diagnostics and so on, then you do want to try to get as broad understanding as possible. And so medical associations and other fora for gathering that input can be very important. So it's a great place to pick up good information at conferences. And that's because you really need to know, like, why doesn't this already exist? And funny, like sometimes it actually does. And I've fallen prey to this myself, where I've come up with this really great idea that would solve this particular problem, and I begin working on it, and then belatedly realize that, you know what, I could just buy this, or there's something that's very close which could be adapted easily, and that's a mistake that I hope we avoid more. The ability to get good information with respect to what products and services are available, and understanding why they might be priced the way they are is part of the trade study of knowing whether the solution may already exist or not. And so trade study is simply identifying what's out there. And that can come from a range of information sources. And I would say librarians are very well prepared and very happy to talk with you about how to do that kind of search, whether it's for patents or papers that are applied in the context that you're interested in, or even product surveys. Once that understanding of, there really is a gap, here's what we want, and those need to be stated clearly as requirements for what the technical aspects of the solution are. And then why don't the current technologies serve that need? Then that helps to define what is it that you really need to work on? Because probably most of the technology, again, already exists and does not have to be invented freshly. But then you can focus on what the critical aspect of the gap is for the most important requirements that the client or patient might need. I wish I could say that you just need to do that once, but in the design process of developing technology, quite often you need to take the understanding of what that gap is, do conceptual development of ideas that turn into designs which you think are going to solve the problem, but then you need to test to make sure that you haven't fooled yourself and that the technology that you've been working on does actually address the requirements that are most important to be met. The art then comes in doing that conceptual design work, development of prototype designs of increasing fidelity with respect to being able to actually do the solution that you need it to do, and then being able to test in ways that, of course, comply with ethics and other requirements, and get you to the point of being able to say that, yeah, you know what, this really is it. It really does work. And we can't actually produce it in the quantities that the market allows us to. And this is a lot of work and has to be done carefully. And thinking up front is important, because if you get too far down the road of commercialization and have to go back and start part of it over, that cycling of iteration gets more and more expensive. So what you try to do is to understand the need well, do early development to determine whether the most important uncertainties have been solved, and then get into prototype testing such that you can say, yeah, you know what, that part of it now works. We don't have to work on that anymore. Let's move on to the next. And luckily, we don't have to invent everything. In fact, we shouldn't. The last thing that we want to do is to be creating designs for components or subsystems for which good solutions already exist. They may need to be adapted for the particular application area, but we should build where we can, or where we must, and buy where we can. Sometimes that seems like a waste. It's like, oh, you know, like these bolts are really expensive. It's like, yeah, and you know why they're expensive? Because they've been designed and engineered and produced and quality tested so that we know what their performance and durability is going to be, and that's not cheap. The advantage of codes and standards is that allows us to focus on what we need to do rather than being distracted by the things that we could do, but for which good solutions already exist. And in the medical realm, and other realms that I've worked in that are somewhat similar are nuclear power and aerospace. Codes and standards are our friends because they allow us to not only speed up the technology development process, but also make it much easier for us to be able to comply with the regulatory requirements necessary to be licensed. The other thing too is that we don't need to start everything right from the beginning. So this illustration is the technology readiness levels chart, originally developed for aerospace, but it applies quite generally. At the lowest level is very basic research. From there, it moves up into proof of concept, understanding of how a phenomenon works and is reproducible, and then configurable for a particular application. Then, whether it's scalable for the real application of interest outside of the lab, and then can it be produced with the level of quality to deliver the performance and durability at the right cost before it finally gets deployed. Most of the things that we are dealing with, they exist as components or subsystems, so they are at TRL 9. They are being sold by somebody, and then we integrate them into something new, which allows us to solve a problem for a particular setting. So we need to remind ourselves constantly that different parts of the technology may already be at very high readiness levels. And that's an advantage for us, not only in not having to design it over again, but also in the timeliness with which we can implement what we're trying to do. So once again, build when we must, buy when we can. That design process, it's iterative and it's also interactive. We need to check in with the customer and spell check our slides to refine the idea to make sure that it actually meets the most important requirements with respect to safety and efficacy. So those are words that Health Canada will say out loud many, many times. Efficacy just means like how well does it work for the requirements that it has. Whether it's reliable, does it have a high probability that it's going to work properly in its intended circumstance for the time that it needs to? And then what does it cost to actually produce it? When going through the design process, we prototype. So a prototype is an approximation of part of the technology that we are trying to deliver. And it goes through a set of stages. The first stage, which is more intended for sort of the marketing side or the user experience side, is a mock-up. So this is a non-functioning partial representation of the technology to get an idea of how it would work if it were actually functional. Storyboards are another approach to that, where you now graphically, or even with photos or short videos, to represent the user experience of the functionality that needs to be delivered in the technology or the process that you're creating. And so again, this is to give an understanding of what does the solution do, even though you're not quite yet at what the solution is. But then you start to develop aspects of the technology which actually do work, more or less. And so that starts to get you into partial system prototypes. So it might be the most important part of the system that you need to have working. And it might not even be working in a functional clinical setting, but simply moving the way that you wanted it to, or heating up properly, or being able to transmit an analog of a fluid properly into a model system. Those are, that's great, because that's then helping you to understand whether the technology is at the point of doing what it needs to do. But it's not yet the technology that is going to be delivered into service. We also have to ensure that it works at the right scale. And that could be, this is now starting to think about getting it out of the beaker or getting it out of the lab to what it would take to actually have it as an instrument or a device that could be in a healthcare setting. So scaling is a way of being able to do the analysis of whether the performance is expected to be appropriate at the functional level that you need it to. Increasingly, that kind of scale modeling can be done numerically. So if you have good calibrated physical models of what the system needs to do and what the response of the patient is going to be to that device, then you can do some of these experiments numerically, but only if you've got a simulation that is validated for the application area that you need it for. Otherwise, we're still in the empiricism realm where we have to do it with physical systems. Then we get to the point where we're actually prototyping. And so it could be a prototype of a rehabilitation device or a sensor integrated into some kind of processing and presentation electronics, which then give you an instrument rather than simply measurement. But it's still not what you're going to be testing out in any kind of clinical setting. You can only do that outside of a research context when you're at what's called a pre-commercial prototype. So in other words, that's something which is now using the kinds of materials and ideally the exact manufacturing processes that would be used in the actual device. Because when you are seeking permission to be able to use this outside of a research setting, then the materials manufacture, assembly, testing are all parts of that certification conformance. And when you get to the point of actually releasing this in a user setting, that in some respects can be a prototype as well. And I mean by that you have, you can have a first release of a product. It might not have everything that the client would ideally wish to have, but as long as it has the most important things that are going to be promoting good outcomes for patients, then you know what, that's probably good enough. So we can start with a less fully featured system and then go from there if it makes sense. So that's called a minimum viable product. And it's used in two circumstances. And again, we're back to marketing and engineering, right? So would the customers like the product or what don't they like about it? And what needs to be done to make the product meet the next set of requirements for filling that technology gap that's been identified. Now, I thought myself and others often say, well, why don't we just take our time and do the full product once? Well, we're back to that cost of changes issue and timeliness to market. You know, when you think of the devices that we carry around all the time, the first iPhone, released over 10 years ago, it had a lousy battery life. It didn't have a lot of apps. It was tiny, but it was a game changer. And so the most important things that the user wanted was the experience of being able to have a telecommunications device combined with a browser and a music player, all together with connection to the internet. And so learning from what the market actually wants is the best way to ensure that requirements in the future are met. If you design without that input, you probably aren't going to get it right. And later on in the technology development cycle, changes get more and more expensive. So by getting products to innovators, those who are willing to accept a reduced feature set in order to apply it early. I mean, so, those clinicians who have a research connection, they're the perfect example, right? It's like, yeah, I don't need it perfect. I just need to make sure that it's safe and that it works. And then we can modify it later. That is a great model for successful technology development and implementation. But remember, if you're going to use it outside of a specific research setting, which has its own set of requirements that need to be met, then it does become a device that has to be approved by Health Canada, and that must have the safety and efficacy, as well as the, in almost all cases, the production quality management sorted out before you get approval. I'll get a bit to that more in a minute. But again, it's okay to have something that's good enough and is safe and efficacious for what it is specifically intended to do, and then improve it later. In the case of a situation where you're not just doing a research project and then publishing the results to be able to get the information out to fellow practitioners and the world in general, you need to think about intellectual property. And that's because that knowledge that has been created it has different kinds of value to different kinds of people. And if a company is trying to take knowledge and create commercial value from it, then you need to make sure that that knowledge is protected in some way. So that becomes what's referred to as an intangible asset for a firm. And there's a number of types of these. Patents are the ones we're most familiar with, and they protect inventions. And that's a thing that has some kind of a function. There are also protections for things like trademarks and design appearances, even plant breeds and circuit board layouts. So those can all be protected in different kinds of ways. Those are formal through an application process to Patent and Trademark Office. There's also informal types of intangible assets, such as technology secrets. So, the 11 herbs and spices of Kentucky Fried Chicken, or the formulation for Coke, or catalyst formulae, or operational information. as well as the know-how to actually implement a solution. And so that's referred to as so-called trade knowledge. And so a mechanical ventilator, it's a technology that the way in which it is used for best patient outcomes is know-how. Who's entitled to a patent? Well, basically anyone who's contributed to the conception and its reduction to practice. So who thought of the idea and who got it to the point where it's seen as being something that is original, that actually works, and is beyond the general knowledge of somebody who's knowledgeable of the art. So, so it has to be something that could actually work. So no perpetual motion machines. In Canada, 2 of us work on something. I can't go behind your back and file for a patent without you. So joint inventors can't act independently, they actually need to act together. The invention itself, it has to be secret. And this is worth just a few seconds of reinforcement that if you make an enabling disclosure, as lawyers would say, then you cannot patent the idea anymore. And so if you're at the point where you are, you have a technology that works and is truly original, then you want to make sure that you do not describe it too completely in a public forum, such as a conference. Unless you're actually interested in just disseminating the information without any possibility of commercial return, or you want to make sure that other people don't patent the idea to try to get commercial benefit from it. There are a bunch of things that aren't patentable. Scientific formulations, just putting a pencil and an eraser together, that's not patentable. That's just simple aggregation. Business plans and methods, not patentable. But also there are a lot of things related to healthcare which cannot be patented. So a method of medical treatment, so that's a method rather than a technology, can't be patented. Multicellular organisms cannot be patented in Canada. And anything that's naturally occurring or a software algorithm can't be patented. But again, if you implement it in a technological framework, so if you have an algorithm for diagnostics that applies to a particular instrument, then the combination of those may be patentable, but the algorithm itself cannot. If you're going to write a patent application, there's a bunch of stuff you have to put into it. Basically, you have to give a brief description and then a very full description, which usually includes drawings, a set of claims of what the invention does, and then a request for the patent. And anything that you can do to put that initial information together before filing, it will reduce your costs and speed things up. Patent agents are very good, but they will not be subject matter experts in the specific technology area. And so your role is really to make sure that that information is delivered as quickly as possible so that you can actually be recognized for having created that new intellectual property. Some of this stuff I'm just going to skip by because it doesn't really apply to most of us. When you're trying to get to the minimum viable product, it gets more and more expensive. And the hurdles to having enough money and enough people to be able to make sure that the technology has been created well gets to be a bigger and bigger hurdle. Plus, you may need particular facilities and equipment to produce the system. So you don't need to create a new venture to be able to create some positive social impact through commercialization of a technology. There's several different ways to do that. One is to publish an enabling disclosure, whether it's through a very complete conference or journal article describing the technology or publishing an open source design, that now prevents others from protecting it. And you thereby have given the intellectual property to everybody. If you want to keep it secret, then you can, you don't have to patent it, but in that case, you have to make sure that the secret doesn't get out. And you could even, give that or arrange for sale of it to others. It's more credible if you actually have a patent in that case. So if you're working with a company and they want to exploit the new intellectual property, having a patent and then, which is, it's like peer review, but this is actually original and useful. And then you could sell it. Or you could set up some kind of joint arrangement to work with a company on its commercialization, or you might end up going alone. Going alone means that you have to set up a business structure. You have to be able to develop the technology to the point where it can be produced with all the resources to be able to construct it, test that it works properly, distribute and sell it, and provide after-sales service. That's a lot. It's definitely easier said than done. So I'm just going to spend like a minute or two on most of these, just because if you want to go down that route, please come and talk to me or some of the other people who I'm going to mention close to the end, because you need a multidisciplinary team to make that happen. So if you're going to create a company, if you're going to be an entrepreneur, you need multidisciplinary knowledge around how to do that, because you're going to have to write a business plan. And that means that you have to describe what the company is going to be, what kind of goods and services they're going to deliver. Do you understand what the market is? How are you going to organize and manage the enterprise? How much money is it going to take to be able to actually set it up and sustain its operations? What's the legal structure under which it's operating? And then how are you actually going to make money? Also, how are you going to ensure that you are able to respond to whatever competitors might be in the market which you're trying to establish yourself? And what kind of financial arrangements do you have in place to be able to develop and sustain the business? When you do that, you will have to tell a lender everything about you financially, because the bank will, so you're going to need to get money. You can get money from a couple of places, and a bank is one of them. Anybody who's going to either lend you money or invest in you needs to trust that you are going to be responsible with the funds that are going to you and your company. Ways to do that are your own personal credit history, as well as having a good plan of what the financial forecast is, which has well-stated and reasonable assumptions, and how you're actually going to deliver it. So in business planning, and again, this is from my experience, here's things to avoid. Please learn from my mistakes. Being too ambitious. Now, masking financial difficulties, I've never actually done that, but you really need to not hide problems, because that could get you into real trouble. You really do need a transparent business plan, and you have to put good focus on ensuring that the management team is well set up, and that the plan of how you are going to sell and what it will take to actually sell is really important. Because a company has, like, here's one model. It's not perfect, but it's pretty good. Think of it as having a whole bunch of things that need to happen. In this particular model, the business model canvas, there are 9 different activities that need to take place. The core of it is the value proposition. So if somebody asks you, how do you make money? It's the value proposition of the company. And everything on the right-hand side of that is how you actually generate revenue from sales. So, who are you selling to? What does the customer want to pay? What's the sales channel? All that kind of thing. How do you make money? It's a revenue stream. How you control costs is how you produce the technology or the goods or services at the right cost, so that you can then sell them at the right price to actually make some money. And that's in a broad sense. This is why, so you need You need business expertise, you need technical expertise in a technology-intensive company, and it's why marketing and engineering are always at odds with each other. However, they are two sides of the same coin. If you're going to start up, so I'll just spend, again, like 2 minutes on this because I'm aware of the time, and I do want you to know that it is highly possible to start your own business. And to do that, you've got to have the right people. It always starts with, do you have a good business idea? Like, do you know how you could make money? And do you have the right people that you're going to be associated with it? Now, in the case of people, in an academic institution, quite often that doesn't mean setting up the business yourself, but it may mean working with an existing company or a new venture that is aligning with the work that you are doing. And that's part of strategy. And strategies are different from plans. And the plan will include all of the resources necessary to be able to deliver on the plan. So money, people, facilities, and those intangible assets, which is the new knowledge that you've already created. There's 3 basic types of commercial operations. Sole proprietorships are just, it's like, like one person, and it's easy, sets up really quickly. Business registration is super fast, but while the owner gets all of the benefits, they also incur all the liabilities associated with it. Partnerships just mean that you have more than one person who's sharing that joy, but still personally liable for the business outcome, which is why corporations are set up, because that limits owners' liability. It gives you a lot more access to capital. Taxation and some of the accounting is more complex, but for anything that's going to grow, a corporate structure is really important, and because that's how you get more money. And having the intangible assets under that corporation's control is also critical. And there's some easy ways to be able to go and create those. And again, business advice is helpful, but it's not that difficult. Anyone can create a corporation or start running their own business. However, if you're going to run a technology business where you are creating a new technology or delivering services associated with that technology, that is engineering. And in Alberta, a company like that has to have a permit to practice from a PEGA, and it has to have someone who's a responsible member to ensure that the authentication and validation of those engineering works is being done under the direction of a professional engineer. And you can actually, one of the companies that I advise, I'm actually their responsible member. None of the team, they're all really young, they're crazy smart, but they don't have their PNs yet. So a role that you can bring others in to do is to provide that regulatory support. Shareholder agreements, I only mention this because if you're going to have a bunch of owners, you need to know what the rules are by which you are playing. That's actually part of a successful business. It's like good fences build good neighbors. Financing for business is increasingly interesting the bigger that you get. You've got 3 choices. If you've got a business that's already existing and you can grow from internal cash flow, in other words, you can take the profits and you can put them back into the business, that's the easiest, sometimes even the best. Borrowing money, now money is still pretty cheap, but it's getting tighter, and has often very significant conditions associated with it, which can directly affect the owners. And if you don't think the bank won't take your house if your company goes under and you have secured the loan, then you're in for a very bad surprise. However, a corporation with its own resources can limit the liability to the owners. Ways to be able to share that joy is to share a chunk of your company by selling equity. So if you've got people that are interested in your company and can provide you the resources to grow, they can either take debt in your company or they can take an ownership share in the company. Both have advantages and disadvantages, which I don't have time to get into today, but I'd love to talk to you about it. You'll hear about series of financing, and basically the farther down the alphabet the series number or letter is, the more money that is involved. Maybe even getting to the point of becoming a publicly traded company through an IPO, an initial public offering. But that actually it's a big deal. It can sometimes impair a company. So a lot of small to medium-sized companies don't ever go public. Okay, so let me finish off just with a few specific aspects around, okay, so what if I want to do this in Canada? Think about the class of device for the technology that you're considering. Class 1, not a big deal. Basically dressings and toothbrushes are class 1. Anything else, you know what, you can't just produce it in a facility without having had the specific device approved. In that case, you must go through a process by which the safety, efficacy, control of risks to ensure its reliability, and that you've got a quality management production system is absolutely necessary. But the inventor and developer isn't the one that has to do that. It's actually the producer, distributor, or seller that has to do that. There are a number of medical device companies in Edmonton, and once again, and regionally, but in Canada, it would have to be a company that is licensed to be able to produce those medical devices. There's a lot of people who can help, and it depends kind of where you are. If you're interested in, it's like, hey, we've been doing some cool research, maybe we should patent this. Talk to the Technology Transfer Services Office. So Joanne Preston is one of the associate directors there, specifically on the health side. Great people to talk to. You can also talk to people at AHS in their innovation area, Alberta Innovates health area, although less directly helpful, but they have some programs that you might be able to take advantage of. ST Innovations, of course, great distributed center, wonderful place to be able to see what it takes to get to prime time. But again, the focus it's more on making sure the technology is efficacious and safe. If you're going to prototype, we have resources on campus, the shack, the garage, which are open for business. So the Elko Engineering Garage is not limited to engineering students at all. If you have an idea that's it's not specifically like a research project for your thesis, and you want to try something out, come and see us. Similarly, on the incubator side, so medicine and dentistry, so they have an innovation hub. Engineering has its ICE incubator. I'm the director of that. eHub in business, and organizations outside, Startup Edmonton and so on, all good people to talk to. Some are more specific than others. Certainly in looking at programs that connect with companies, keep an eye on what's being distributed, because there may be opportunities to have to be involved in programs that link you with companies. Those are almost always good. But remember, never tell somebody the most important core idea, that enabling disclosure, unless you've got intellectual property protection. Of course, within the U of A itself, definitely want to talk to Parmita, and also folks in eHub, and from the technology production side, certainly come over and talk to us. Okay, so with that, so it would be a long journey, could be extremely valuable to society to take something from the proof of concept or the early clinical assessment stage to market. And it requires some understanding and supports to get there. And there are lots of people on campus here and in the region willing to help you with that. I will make these slides available, and my email address is on the last slide. So whatever I can't answer now, I'd be happy to follow up with you later. So with that, thank you very much for your attention, and I'd welcome any questions.
Thank you very much, Mike. This was right on and covered some very critical information in a nice overview that put it all together. So thank you very much for this. Do we have any questions? And please, everyone, if you are able to turn on your cameras so that we can have the feeling of a community having discussions, that would be wonderful. And while people are turning on their cameras, Mike, I was intrigued by your first statement about marketing and engineering and the way you put it together. That marketing basically trumps engineering at the beginning, at the end, and engineering is how much you're paying for it, right? So can you remind me who said that if you want to take your product to market, you need to kill the engineer? Can you tell me? I've heard that multiple times. I just can't remember the original source.
I'm not sure. It's variously attributed. Yeah, because the reality is, so again, some of the things that I teach our engineering students is that, so in a business organization, so a technology-oriented business, engineering is all about, it's all about design, delivering projects, and operations. The value propositions associated with those, like we're told what those are. And the engineering function is a service to delivering the commercial value of the company. And from that standpoint, well, any profession, it provides a service to others. In companies, typically it's it's accountants that are, they link strategy to, how much are we going to spend to be able to make this much profit off of something. And then after that, then it gets to the engineers. It's like, okay, this is what we want. This is all we want. Don't give us the Cadillac version. We just want this. And we need it, this fast for this amount of money. And so, yeah, I wouldn't kill the engineers, but the engineers have to recognize that, their contribution to that value proposition is a little less than sometimes we think. So the first company I was ever a part of creating, like all engineers, we just wanted to build robots, and and everybody wants to buy robots. Boy, were we wrong. But we didn't go broke, because we then engaged those who did understand that you actually need to understand what people are willing to pay for and give them that.
Right.
And so in a lot of cases, it's not the technology itself, it's the information or the service that the technology delivers that people are willing to pay for. And so whether it's data as a service or diagnostics or whatever, that we have to remember that the technology is in the service of people and sometimes accountants, and not the other way around.
I know that there are going to be other questions, but let me just follow up with one question that I do get asked every now and then. When is it enough? Right. So especially when you want to say, I want to take my technology out of the lab now. Okay. When is enough enough?
That is.
What is enough? When is enough?
That is the core question. So the first part of the answer. So as the technology developer, I can't answer that question. I have to go back to the people that I've been working with to say, will this meet your requirements? And just the most important ones. And if they say yes, then that's now enough. Provided you've also thought about sort of the rest of the story of, I don't know, if you want to make a spinal implant, then it's not just have we created a design in a particular material that would give the proper support to the spine in these circumstances, but there's a whole bunch of other things around, how will it be produced? How we have the quality assurance associated with it? What's the method for the implant to be surgically installed, and how are you going to ensure that it's going to last, well, as long as the person lives? So in that case, it's if you can't answer the safety and efficacy and reliability questions, then you have to keep going.
Excellent. Questions from the audience? I can continue with some of my questions, but let's go with Michelle. Michelle, go to you.
Yeah, I just wanted to ask if you've run into problems where you want to develop something, but somebody's holding a key patent that kind of stops you from pursuing that. Just if you could comment on that situation.
Yeah, that sometimes happens. So there's three basic routes around that. So the first is that you negotiate a license from the patent holder, and which may or may not be successful. The second is to examine the claims and description of the patent very carefully, and then create something that is sufficiently different that you can get your own patent. And that is completely above board and legal. The riskier one is to simply ignore the patent and wait to be sued. I don't recommend that one, but companies do that all the time.
Yeah, good question, Michelle. Dan.
So what's your recommended source for funds for patenting? Because the biggest issue that we've got, we do a research project, we do it with NSERC or something, and then there will be no ability to use that money for legal fees or patent and something else. I think it's very, very expensive, more than a discovery grant, for instance. So what are these available options for someone who could be patenting like 3 or 4 times a year, but just financially cannot?
Yeah, great question, Dan. So for the individual researcher, there are a few programs through Alberta Innovates that provide essentially like business associate support to be able to prepare the patent application. Most grants absolutely do not allow you to use those funds. They are ineligible to patent. I've been working with the VPRI office around what might be possible for that, but we don't have anything internally yet either. The short answer is that the options are quite limited for that, and that was part of the reason why I said, make sure that you've got you've done as much of the legwork as possible to reduce the patent agent and filing fees, and also think very carefully about what jurisdictions you want to file in, because some of those patent maintenance fees are more expensive than others. With care, some general research funds could be used to pay for initial application and maintenance fees, but again, the onus is on the individual to ensure that those are eligible costs. Some of the consortia do allow patenting costs to be a part of it, as long as they get a bit of a cut out of it.
CIHR is now allowing patents, partial patent fees, so something to look into as well. Anyway, I know that we're out of time, but I do want to ask one question, especially with the large number of trainees that we have on the call. For trainees who are interested in the future commercialization or even getting into industry, for early, even professors who are early in their process of entrepreneurship, I know you mentioned some resources, but what should they be taking advantage of right now? So trainees, are there courses that they should be auditing or workshops that they should be taking? What would you suggest for them to be preparing themselves so that when the time comes, they really know what needs to be done in a way that will set them for faster success?
Thank you, Vivian. That's a great question to kind of end on. So eHub, so that's the School of Business's entrepreneur hub. They're very good, especially on the marketing side. On the technology side, we have, through the ICE incubator, and I put a link in the chat to that, we accept applications from student-led groups. That you don't have to have your own company. If you just, if you're trying to explore the idea or trying to see whether some early technology commercialization or technology development would be possible,
right?
so we have currently 5 teams. We also have 2 startup companies started by, in one case, like a PDF and a postdoc, another by undergrad students who are doing exactly that. So they work with mentors.
Yeah.
There's a venture mentoring service as well to be able to do that. So if there are people who they just want to talk to somebody about, hey, like, could this be new? Is this something that we might want to take forward? Then please email me or contact me, and I'd be happy to have a conversation with you. We have several mentors who are specific in sort of the healthcare area who can help give you some of those conversations. So those are just like, within the SMART Network and ST Innovations, that it is really a community that helps new innovators to be able to create their own success.
Wonderful. That's a great note to end on, Mike. Thank you so much for this great presentation. And hopefully this is something that is of great value to everyone as we think about what is the impact of our research going to be. Thanks, Mike, and thanks everyone for attending, and we'll see you next month.